Problem 1 says determine the following limits. Briefly explain your thinking on parts B and C. If you apply L'Hopital's rule, indicate where you have applied it and why you can apply it. Print your final answer in the box provided. So the goal with limits is to always try to do direct substitution first. And if the limit works out and gives us a real number, then we know that we were allowed to do that and we can simply move on. So it even tells you here no explanation is needed for part A. This is a polynomial, and polynomials are functions where we know direct substitution will work. So to evaluate this limit, I just need to plug -1 into our function. So -1 to the 7th minus 4 times -1 plus 2. A negative number raised to an odd power is going to come back as a negative number, so it's just -1. -4 times -1 is +4 plus 2, and this works out to be 5. So our final answer is 5. And don't forget to put, if the box is there on the problem, don't forget to put that as your final answer. For part B, we have the limit as x approaches -infinity of x minus 1 over the absolute value of x minus 1. So remember, when you have an absolute value in the problem, we sometimes have to change the problem slightly or rewrite the problem so that we can actually evaluate the limit. So you do have to provide some kind of explanation for your answer here. So all absolute value functions are actually piecewise functions. So the absolute value of x minus 1 can be written as a piecewise function where the first piece is all the values of the function that would have positive y values if we just left the expression alone. So this function is just the line x minus 1 when x is greater than or equal to 1. However, if we look to values less than 1, we're actually looking at the original negative values that the absolute value function then folded up and made positive. So we rewrite the same expression, but then we negate the entire thing. And that's why I needed these parentheses here. So this is what's happening for x's less than 1. Now, this function has a domain of all real numbers, so I had to put 1 somewhere. I chose to put it here. So it was perfectly acceptable if I had just said greater than 1 and less than or equal to 1 here. But you can't include it with both parts. So now that I've got my piecewise function, well, x is approaching -infinity. That is definitely values that are less than 1. So I can rewrite my expression substituting this for the absolute value term. So this is the same thing as the limit as x approaches -infinity of x minus 1 over negative quantity x minus 1. So the x minus 1's actually cancel, but don't forget about the negative sign we have down here, and so this limit just simplifies to -1. The next function, if we try to do direct substitution, we have e to the 5x in the numerator. E to the 0 is 1, so 1 minus 1 would give us 0. And in the denominator, if we plug in 0, we would get 0. So what we have here is an indeterminate form of 0 over 0. So this is, in fact, a candidate for L'Hopital. So we have to not only indicate our justification for L'Hopital, we also have to indicate that we're using it. So I just like to throw a little LH over the equal sign for the step where I'm about to apply L'Hopital. So from here to here, I'm going to take these derivatives, and it's going to make the limit look dramatically different. So that's why we need to make sure we let whoever's grading our papers know what we did. So to apply L'Hopital, it's the derivative of the numerator over the derivative of the denominator. So the derivative of the numerator is 5e to the 5x, and the derivative of the denominator is 3. Now I'm going to try direct substitution again. If it works, I'm done. If I can't do it, I would have to use L'Hopital possibly again or try some other algebra move. So 5 times e to the 0 is just going to give us 5, and 3 is just going to be 3, so we get an answer of 5/3, and we're done. it is possible to have a problem that requires some more algebra. So if you go back and look at the video for I think it was problem 1 on the spring 2018 exam, you'll see that we had a L'Hopital problem that actually required a few more steps to it, and you can see when it was appropriate to write the LH and when it was not appropriate.